All right, looking at our next lesson here using linear equations. Going to be solving some equations for y, graphing from all the different forms. So first little warm up here to get started, solving for y. So basically we're taking all these and we're going to put them into slope-intercept form. So for that first one, we don't only have one step. We would divide by -2. So we got to divide everything on each side by -2, and we'd end up with y equals, it's 1/2, and negative divided by negative becomes a positive, so 1/2 x minus 7/2. Okay, for the next one, we have a fraction times y, so we're going to multiply by the reciprocal, 4/3. So from there, we got x times 4/3, so that's going to give us 4/3 x minus 6 times 4 divided by 3, which will give us -8. Okay, and then the next two, they are in a standard form, so we're going to have two steps. First, we got to move that x to the right side, so -2x. So I'm going to write it over here. So we got 3y now on the left equals 6 minus 2x. And then we would need to divide everything by the 3. So it gives us 2 minus 2/3 x. And then the last one, two steps again. First, move that x over, so minus 1/2 x. So we got -4y equals 8 minus 1/2 x. And then we're going to divide everything by -4. So y equals 8 divided by -4 is -2. Negative divided by negative makes this a positive, and 1/2 divided by 4 will give you 1/8. So there's all four of those solved for y. All right, so goals today, constructing linear equations to model relationships between two quantities. We're going to graph the lines from slope-intercept, point slope, and standard form, and convert equations from point slope or standard form to slope-intercept, which is what we were just doing. We were solving for y, converting to slope-intercept form. All right, moving on to the next page. It says, describe what we know about the graph of each relationship by analyzing each equation, and then explain how you might graph each line given the equation. So that first one is in slope-intercept form. Y equal mx plus b. So we know the slope and we know the y-intercept. My slope would be 2/3 and my y-intercept would be 7. So to graph it, I would start at my y-intercept and then use my slope of 2/3 to go up 2 and right 3 to find my next point. Second one is in point slope form. Y minus y1 equals slope x minus x1. So we can pick out a slope, which is 5, and our point. So remember for point slope day that if it's x plus 1 in the equation, that means x is -1. And if it's y minus 3, that means y is really +3. So from point slope form, we're going to start at this point. And then again, use your slope to find your next point. We'd go up 5, right 1, using our slope. Third one, we just have an x. There's no y. So if you think of our graph, when we just have an x, it's a vertical line going through the x-axis. So that's what we're going to say here. This is a vertical line through -4 on the x-axis. And then the last one, number 4, we are in standard form. So standard form is the only form we cannot graph from directly. We're going to solve it for y and then graph it. So we're going to move the 3x over, so plus 3x, just like we were doing on that warm-up. And then divide everything by 8. So if we reduce 10/8, that becomes 5/4 plus 3/8 x. So again, we're in slope-intercept form, so we could use the slope and the y-intercept as our starting point. Okay, moving on to our next page. So using slope-intercept form to graph a line. So as we learned previously, slope-intercept form of a linear equation is y equals mx plus b, where m is our slope and b is our y-intercept. It's our starting point. So you can use that to graph starting at the y-intercept. So this question here says Douglas is giving away tickets to a concert that he won from a radio station. Currently he's got 10 tickets, so there's his starting amount. Currently he has 10 tickets and he gives a pair of tickets to each person who asks for them. So his slope, as he gives tickets away, it's going to be a negative slope. He's giving 2 to each person. So I've got a slope of -2 to each person. So to graph that equation, we got y equals -2x plus 10. Like the graph is shown here, we're starting at the y-intercept of 10 and we're going down 2, right 1, using our slope. So if your slope is negative, we should end up with a line that's going down from left to right. If our slope is positive, we should end up with a slope of a line going up from left to right. Okay, so we're going to graph these examples using that. So for number 1 here, my slope is 3/2 and my y-intercept is -1. So we're going to start at -1 on the y-axis. And we're going to go, since my slope's positive, we're going to go up with the top number. Up 3, right 2. And you can keep doing that if you want more points on that line. And there is our line. Mine's a little wavy, but there's our line going through those points. Okay, same thing on 2. This one has a slope -5/2 and a y-intercept of 3. So now we're starting at 3 on the y-axis. Slope's negative, so we're going to go down with the numerator. So down 5, 1, 2, 3, 4, 5, right 2. Again, we can always just double check when we're done the direction of the line. It was a negative slope, so it should be going down from left to right. If it's not, we probably just counted the wrong direction with how we are moving our points. Okay, one more from slope-intercept form on the next page. Slope of 10, y-intercept of 25. All right, just got to be careful here because our graph is counting by 5s on the y-axis. So starting at 25 would be here. So to go up 10 and right 1, this would be up 5, up 10, right 1. So be wary of how your axes are counting by, how they're scaled, because it's going to change how many units you count on the coordinate grid as we move. Moving up 2 units there was moving up 10. All right, so now coming to some word application problems where we're going to write the equation, and then once we write the equation, we can then graph it. So Avery wants to buy a virtual reality headset. He already has $30 saved, so there's his starting point, his y-intercept. And he plans to mow lawns for $15 each. Keywords like each or per tell us multiply, which is the word that's going to go with our slope, because we're multiplying that by whatever our independent variable is here. So that's an equation of y equals 15x plus 30. So if we graph that, we're starting at 30, and we're going up 15, right 1. So this is counting by, it's like tens. It's 10, 20. So to go up 15, it's going up 10, and then up 15 would be one more half of a unit, and then right 1. So we'd be moving over to about right there. Okay, to make it more exact, since we're counting by tens, we can increase that. So instead of going up 15 and right 1, we could go up 30 and right 2. So 10, 20, 30, and then right to 2. It would give us a little more accurate point that falls exactly on some grid lines. So there would be our graph there. Slope-intercept form, slope of 15, y-intercept of 30. All right, next one, Jasmine's working on her golf swing when she hits a golf ball through her neighbor's window. To replace the $150 window, Jasmine is paying her neighbor $10 of her tutoring each week. So she's got a starting value that she has to pay off, a y-intercept of 150, and she's got a slope. She's paying it, so the value is going to go down that she owes. So negative slope of 10 each week. Again, there's the keyword each. So we're starting at 150 and we're going down 10, right 1. Okay, if you always use the negative with the top number to decide up or down, we're going to go right with the bottom number then. So this graph looks like the y-axis is again counting by tens. So to go down 10 would just be 1 unit, and then right 1 would be 1 unit. So we get a graph that looks like that. And if you went all the way to where she would have paid it off, you'll find that it's after 15 weeks. So there we go, which makes sense. If we started with 150 divided by 10 would give you 15 weeks till she's paid it off. All right, so now we're going to move on to graphing from point slope form. So the only difference here is where we're starting. We're starting at a point instead of starting at a y-intercept. So basically just changing the point we're starting. So as I said in the previous lesson, we learned point slope form as y minus y1 equals our slope, and then parentheses x minus x1, where m is your slope and xy is a point on the line. So we're going to write an equation from this situation in point slope form. So it says the jazz band is selling tickets to raise money for new music. They already had some money in their bank account when they started selling tickets at $5 each. After selling 3 tickets, the band had a total of $50. Well, there's our point. We got a point. After 3 tickets, they had $50. And here's our slope. Notice that keyword each again. So we got a slope of 5. So if we're going to put that in point slope, x1, y1, we'd have y minus 50 equals my slope, and then x minus 3. So there would be our point slope form equation. So if we want to graph that, it says use the point slope form, write the coordinates of the point we know. We know we're starting at 350. So 3 up to 50, it's our starting point. And then we still use our slope to count the next point. So our slope's 5. So we're going up 5, right 1. And this graph is counting by 5s between the coordinate grid lines. So up 5, right 1 would be there. So there would be our line using point slope form. All right, more examples, similar. Now we're just being straight up given the equation, so that's what we're going to use to graph. So for A, we got a slope of negative 3/4, and you got a point of x is 14, y is 5. Because remember from point slope form, if it's minus in the equation, that means it was positive in the point. So 14, 5, if we plot that point, would be here. And then our slope's negative 3/4. So this grid is counting by 1s. So we're going to go down, since it's negative, 2, 3, and then right 4. 1, 2, 3, 4. Now, we ran out of graph space. So if that happens, we can always go the opposite direction. So in other words, if I was going down 3 and right 4, I can also go up 3 and left 4. And I end up with a point on the same line. So we run out of grid space on the graph, just go the opposite direction for both your vertical and horizontal change, and you'll end up with a point on the same line. All right, for B, same thing. We got a slope of 1/2 and a point. X plus 6 means x is negative 6. Y plus 8 means y is negative 8. So negative 6, negative 8 is right down here. So there's our starting point. And now we have a positive slope. So we're going up with the numerator. So up 1, right 2. So there is our graph of that line. All right, another application problem using point slope. Vivian and her friends are spending their Saturday making friendship bracelets to donate to the local children's hospital. The group makes 7 friendship bracelets each half hour. Vivian had already made some bracelets Friday. After the group worked for 3 hours on Saturday, they had a total of 45 bracelets. Well, there's our point. 3 hours, 45 bracelets. Now, the trick here is our slope. We're talking about per hour based on that point. So if she makes 7 in a half hour, 7 each half hour, that means in 1 hour, she would make 14. So we got to have a slope of 14. So if we're going to write that point slope equation, we'd have y minus 45 equals 14, and then x minus 3. So now we got a graph we're going to create ourselves. You'll notice it's not numbered by anything. So we got to have a point where we can go up to 45 on the y-axis. So it might be a good idea to count by, say, count by fives. 5, get my pen to work, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. So I skipped lines counting by 10s. That means each line is counting by 5s. For the x direction, the hours, we can just count by 1s. To make it space out a little bit, I'm going to make every grid line a half hour. So 1 hour, 2 hour, 3 hour, 4 hour, 5 hour. Now, there's no wrong way to do that as long as you can fit your data on the graph. We could have two graphs that look different based because we've scaled them different, but they could both be right. So if we start at the point 345, on my graph it is here, and I got a slope of 14. So it's not going to be exact based on our grid lines counting by 5 or 10 fives, I should say. So we're going to get it close. Go up by 14 would be up 5, 10. Third line would be 15, so just under that line, and then right 1. So over, ooh, my grid moved. Let's try that again. I'm going to rewrite it real quick because I touched the screen wrong and it all moved on me. 10, 20, 30, 40, 50, 60. All right, let's try that again. Starting at 345 would be here. And then going up 14 would be up almost 3 grid lines, because 3 grid lines is 15, and then right 1. So it's a right there. So it becomes more of an approximation when you're graphing that. But there's about what our line should be looking like for graphing a slope of 14. Up 14, right 1. All right, next page, standard form of linear equations. So they're giving us an example to start with here on activity 3.3. Tickets for a school play cost $5 for students and $8 for adults. On opening night, $1,600 is collected. So they gave us the situation model by 5x plus 8y. So x is the number of students, y is the number of adults, equal to our total of 1,600. So that equation is in standard form. It is not in slope-intercept form. Standard form is the only form we cannot graph directly from. So we're going to change it to slope-intercept form by solving for y, and then we can graph. So if we were going to do that, we would first subtract the 5x over. And then divide everything by 8. And if we got 1,600 divided by 8, gives us 200 minus 5 over 8x. So we could graph from that using a y-intercept now of 200 and a slope of negative 5 over 8. Okay, but first we're going to explain on number 1 here what each term of the equation represents in the problem. So 5x is representing cost of a student times number of students, because x is the number of students. 8y is representing the cost of an adult times the number of adults. And C, 1,600 is representing our total cost. Okay, our independent variable. Remember, that's your input. That's your x here. So if we want to know what our independent variable in this context, the number of student tickets, our x value. Now, could this equation be written differently and still solve for y if we had assigned y the student tickets and x the adult tickets? Yes. It would just be a function written in a different form, taking the adult ticket as the input value. All right, next page. Remember that the y-intercept, 0y, is where the line crosses the y-axis. So the value of x at the y-intercept is 0. It says to calculate the y-intercept, we can substitute 0 for the x and solve the equation for y. So again, the x-intercept is where the y is 0. Like this is saying, it's always the opposite. The y-intercept is where the x is 0, and the x-intercept is where the y is 0. So to calculate an x-intercept, we can substitute 0 for the y and then solve the equation. So using that previous equation, going back to it, it was 5x plus 8y equals 1,600. So if we want to know the x-intercept, if we plug 0 in for the y, 8y goes away, and we're left with 5x equals 1,600. And all we'd have to do from there is divide by 5, and we get x equals 320. So an x-intercept of 320 down here on the graph, what that means is if we had 0 adult tickets, that would mean 320 student tickets would need to be sold in order to come to a total of 1,600. Okay, we could use that in our slope, or we could go back and calculate the y-intercept. And then we have 2 points we can graph our line. So taking that same equation, if we now substitute 0 for the x, all we're left with is 8y equals 1,600. And if we divide that by 8, we get y equals 200. So our y-intercept is 200. So in that context, we would need to sell 0 student tickets and 200 adult tickets in order to have the total of 1,600. So if we draw our line between those two, there would be our graph of that situation. Now, determine the slope. Easiest way to do that, go back to how I solved it for y back on our previous page. And our slope was -5/8. So that is the slope of this graph. You're going down 5 units and right 8 for each term of that slope. All right, next page. For each equation, determine the x and y intercept and the slope. All right, so again, a little trick I'm going to give you now for slope from standard form, -a/b. Yes, we could just solve it for y and pick it out, but if you pick out -a/b, that determines slope. And we're talking in standard form. A is the term, the coefficient x, b is the coefficient of y for that term, and then c is the constant you're equal to. So for the first one, I'm going to do slope for each one. My slope there, -a, -5/b, which is 2. There's my slope. For the second one, a is 3, so -a/b. There's my slope. So if we solve those for y and put it in slope-intercept form, we would find the same thing. For the third one, -a/b. Now we do need to simplify that because 2 negatives become a positive when we're dividing, so 2/3. And then for the fourth one, -a is -5, so -a would become +5/b, so 5/7. Now, x-intercept, that is where my y is 0. So for each one of these, and I'm going to work one and then let you pause it and try the other ones, and then you can unpause it and check your work. So for the x-intercept for the first one, that is where the y becomes 0. So all we'd have to do is divide by 5, and we're going to get 6/5. Now if I go back and do the y-intercept is where x is 0. So if I plug 0 in for x, the x goes away, and I have 2y equals 6. So I can divide by 2, and I'm going to get y equals 3. So 0, 3 would be my y-intercept. So again, now would be a good time to pause it, see if you can find the x and y-intercepts on all of those, and then unpause it and check your work. All right, so the x-intercepts you should have got were 7 over 3, 9 over 2, negative 11 over 5, and then your y-intercepts you should have got for the next three were 7 over 4, negative 3, and 11 over 7. So hopefully you got those. If you didn't, go back and check your work if you missed any of those. Again, just plug the zeros in the correct spots and then solve. Okay, 7, what do you notice about the relationship between the constants A, B, and C from standard form? Okay, so again, going back to those tricks I taught you, the x-intercept, at least for the slope, I'm going to introduce some tricks for the x-intercept now. The x-intercept is always C divided by A. If we move back to the first one, C divided by A, 6 over 5. The y-intercept is always C divided by B. Again, talking A is determined from a coefficient x, B is a coefficient of y, C is your constant. And your slope, it's the trick I gave you, is always negative A over B. So you can always use those as a shortcut to find your slope, x-intercepts, and y-intercepts. All right, so matching up these. So they all have the same y-intercept. We can tell they have different slopes. So let's look at the slopes of these. For A, if we use that trick to find slope of negative A over B, that slope would be negative 3 divided by negative 12, which divides to be 1 over 4. For B, that slope, negative A over B, negative 6 divided by negative 2 is 3. And then for C, negative A over B divides to be 1. So looking at those three, the larger the number, the steeper the line is going to get, based on what we've looked at before. So a slope of 3 would be our steepest. So that is line 1. The next steepest, slope of 1, that would be your middle one, line 2. And then the flattest line has this number between 0 and 1, this fraction. That would be line 3. All right, again, now would be a good time, pause the video, see if you can try these. You're gonna write an equation in standard form, try to graph the x and y intercepts. Okay, unpause it, check your work. Okay, so the equation you should have got on 9 is 20x plus 50y equals 500. So 20 calories Ashley's burning every 5 minutes she jumps rope, and 50 calories she's burning every 5 minutes she runs. So those are our 20 and 50. Our values of x and y represent 5 minutes jumping rope versus 5 minutes running, and then her total calories burned. Okay, so if you graph those, you should have had a y-intercept of 10, so 0, 10, and then an x-intercept of 25, 0. So just making some points out here. 25, I didn't count exactly. 10 up here and getting a line going down like that. And then for 10, hopefully you got this. You should have equation 4.5x plus 6y equals 270. So again, that is now 4.5 per student, $6 for an adult, and then a total ticket cost. So if you graph those intercepts, the x-intercept, where y is 0, if you divide, you're going to get 60. And the y-intercept, where x is 0, you should have got 45. So x-intercept somewhere out here at 60, y-intercept somewhere up here at 45. So again, got a graph that looked about like All right, for the next activity, 3.4, again, I think this would be a good one for you to try. Unpause it, and then I'm going to give you these slopes and y-intercepts you should have gone. So for 1, you should have got a slope of 11 and a y-intercept of -9. For 2, you should have got a, you wrote y when I should have written slope. I'm sorry. So slope of 11. There you go. For 2, we should have got a slope of -2/3 and a y-intercept of 0.45. For the third one, you should have got a slope of 10 and a y-intercept of 0.45. For the fourth one, you should have got a slope of -3/4 and a y-intercept of 0.3. Fifth one, solve for y, get a slope of 6, or just pick it out from point slope form, and a y-intercept of -27. Number 6, you got a horizontal line. That's a slope of 0. There's no x, just a y. So your y-intercept is 9. 7 should add a slope of 1/3 and a y-intercept of -4. 8, we should have had a slope that's undefined because it's a vertical line. There's only an x, there's no y, which means there's no y-intercept. All right, wrapping up. For each context, complete each task. Write an equation in slope-intercept form, point slope form, and standard form. State the form of the equation used in your reasoning. Graph the line using any method. Explain the graphing method you used and your reason for using it. So this is another one. I'm going to end it with this being your little ending assignment for this lesson. We will talk about it in class. So make your best attempt to see if you can write those equations in both slope-intercept form, point slope form, or standard form. You pick the form that matches the situation best, and then we will see if we can graph it from there, and we'll talk about our results we had in class.